This is Dania speaking from the AI Guild. We are starting the highest standard in AI live session for the next 30 minutes. So if you're watching live, thank you for tuning in. And you can feel free to send your questions to us via chat. Today I have with me a guest, Mark. Would you like to introduce yourself to our audience?
Yeah. Hi, everyone. My name is Mark Moyou. I'm a senior data scientist in NVIDIA. And thanks for having me on the show.
Yes, really happy to have you here. So, Mark, you are joining us also as an AI Guild member. Can you tell us a little bit more how you found out about the AI Guild?
I actually stumbled upon the AI Guild on LinkedIn. So whatever you guys are doing is working well. And I'm across in the US in Florida, right? And so I'm not necessarily in the European region. So I was actually quite excited to see the breadth of offerings and the breadth of the community. I find it to be a lot more in depth than some other communities that I'm a part of. So super excited.
Oh, thank you, thank you. And can you tell us a bit more how you started in data science, about your journey up until now as a senior data scientist at NVIDIA?
Yeah. So NVIDIA is a company I've looked at from afar for a very long time. I'm originally from Trinidad and Tobago in the Caribbean. So if anyone is from the Caribbean, feel free to reach out. And I came to the States in 2006. So my journey is a bit sort of winding from that perspective when it comes to, hey, did I always want to do data science? It was something I more or less stumbled upon and was brought into. So I originally did chemical engineering as my undergrad,
Mm-hmm.
and from there I decided I didn't want to work in a lab, so moved
Yes.
on and did my master's in systems engineering because I was lucky enough to get a scholarship. And then from there, I met my advisor. I was doing that particular degree in systems engineering. I had nothing necessarily to do with machine learning. And he invited me to take a summer class. That's where I learned, when a professor invites you to a summer class, that means they need numbers, not necessarily because you're the best student. So I definitely struggled through there. I was not a programmer. So certain things I'm going to highlight about my story, I think, are great to take away because I want to show several things, right? That you can come from a small school, you can come from a non-programming background, but
Right.
also, make your way in machine learning, so to say. And so I really enjoyed my time with my advisor. Didn't get a job in Microsoft after my master's. I did have an interview, and I had a friend on the interview panel, and he was like, "Hey, yeah, I think you're gonna get an offer." So I was super excited. Didn't work out, so I went to do my PhD and kind of jumped into that boat. I focused on a lot of fundamental computer vision, not necessarily deep learning based computer vision. And from there, I got a job at a railroad company. So another piece I want you to take away from my story, I went to Florida Institute of Technology. You, in my mind, I think probably would have never heard of it. And from there, I did a internship at Alstom Transportation. So you all might be familiar with Alstom Transportation, at least in Europe. And I was one of the first members of the data science team in North America. So another thing that you learn is everything that they teach you in school. When you get into work, it all depends on the compute that you have in order to do all of the data science that you want to do, right? So back then we only had laptops. You don't get servers and all these fun things to
Yeah.
um, do everything that you see kind of online. And so I spent almost 2 years there, learned a lot in the railroad industry, and then moved to enterprise search and recommendations at a company called LucidWorks. They're in San Francisco. They're about like a 300-person startup. And so I got to work with a lot of different brands, banks, healthcare, anyone who's trying to search over data and then correspondingly do recommendations. You ended up learning a lot about search engines, how NLP
Mhm.
works, and also see the big shift that's coming uh, in search, kind of driven by BERT and what Google has sort of put into place. And then I sort of stumbled upon NVIDIA. I was actually a reference for a friend of mine who was getting hired on a team. So when I was speaking to the hiring manager, and he was like, "Hey, do data science with customers." I was like, "Listen, I could do this too. Let's have a chat." And that's how that led me to coming to NVIDIA. but I'll tell a different story a little later on about
Mhm.
what it takes to get to NVIDIA.
Okay, interesting. So you came from a background where you didn't really have programming skills and you picked it up, and then you focused on search and recommendation applications of machine learning, right?
Yes. So I think
And
so. The one thing there is, and I'm at least some of the things that I will share. I intend for for the audience to have a particular lesson that they can adopt. One of the skills that I think I have of developed over time is coming into a completely new industry, right? Not necessarily knowing anything about that industry, but having very, very strong fundamentals. You then map that particular industry to whatever machine learning problem that you're working on.
yes, right. So because this is related to what I was thinking. So you basically really focus learning about search and the applications of search, but if I understood it right, you were doing that for many different kind of industries, or this, let's say, the subject of search was different.
Yes.
Can you
Hmm.
tell a little bit more about that?
Yeah, I think it's a very search is such a beautiful problem when it comes to it is very complex. It is very personal. And I think people are being conditioned by Google. As you search on Google, right?
Mhm.
Google, people freak out like Google knows certain things, right? But they're trying to take this space of billions or even trillions of documents, right? And a document is could be a website, it could be a PDF, it could be a video. All of those things constitute in actual research terms like a document, and they have to now narrow that entire search space in under, let's say, 25 to probably 85 milliseconds when you put in a particular query. So with that in mind, when you think of search, there were traditional ways of doing search, right, where you basically do like a keyword analysis. Think of it like that, and that's how you match across particular words, matching letters overlapping and whatnot, even across different languages. And what you learn to appreciate, at least in production level search, is there is a lot of context, of business context, that you can inject into search and inject into the way that results are shown to users. So, for instance, if I'm at a healthcare website, there are certain things that that particular website should understand about me when I go to, let's say, ask for a particular doctor, right? And then, I know we're going to get into how much information someone has on you, but at the same time, it's all about efficiency, right? And almost to some degree, getting you the right things that you need when you go to shop. If you have to go through a store that has 10 million products, you probably won't
Mhm.
buy anything, right? So there's a very delicate balance between what everyone wants and what's more favorable to you.
Yes, and I was also thinking, for example, when you were mentioning the idea of search and having this in production, that this is what we are also pushing for at the AI Guild. So our mission as a community is to advance AI adoption, which means going beyond proof of concepts or going beyond just the MVPs, but really working on robust AI, which means that solutions should be deployed, should be maintained in production,
Hmm.
and also in a way that the company that is putting that offer to their customers, could be internal customers or external customers, but that they're confident that it provides value, but also respects their privacy. And you briefly touched on that, for example, when we talk about healthcare, but also in simple e-commerce, there is a lot of data regarding what the customer is doing in the platform, or even about the finances and kind of payment methods and so on.
Hmm.
I don't know if you have experienced something like this when working, especially working with other companies, if there was any way to address this or any experiences you can share with us.
Yeah. So the first thing I would say there, let's say if you take e-commerce, right? Um, when you're shopping, imagine you had a really poor shopping experience. Okay, so you go to an entire mall and let's say you're shopping at some particular fashion outlet, let's say. But now, when you go to that fashion outlet, in reality, you get a smaller store, right? There's a very small selection of items. And let's say most of the things might not fit you, or they might not have your size. They might not have the style that you like at that location where you are. Now, the advantage of when you've come online is that same tiny, small physical store is now this massive building, let's say. Okay. But now you have to spend the time combing through a lot of those things to find things that relate to your preference. And I think you take it on an industry by industry basis first. Like if you broke the problem down in terms of how deep into a person's information that you go to deliver a really good experience on, let's say, your search, right? When it comes to, so let's come back to e-commerce, right? If I know there's particular styles, so a lot of it to some degree comes down to classification, right? On the vendor side, where you come in, you're from a particular location, it's this time of day, I know your previous order history. And another thing, as your machine learning scientists on the call think about, is the variation of the data that you're serving to someone as well. Okay, so the more varied your data to some degree, the more information you need to narrow that space that you're trying to deliver. So if I'm just searching for shoes, shoes is a very expansive space, but it has very defined categories. And I think one way that you can, let's call it reduce, I don't want to call it bias, but reduce the need for a lot of information from a user is really good cataloging. Right? And cataloging is a very difficult problem because how I segment a space of products is very different to how you may segment a space of products. And that's the challenge that most e-commerce businesses face. So there's a lot of folks that do machine learning now to actually automatically classify products into some generic hierarchy. And that's kind of the beauty of where search is headed to, with more semantic based search. Before, I need to put a particular category, excuse me, put a product into a particular category, right? So it's very defined. And that category is, yes, it's human, understandable, but within the limits of, let's say, lexical based languages,
Mm-hmm.
you're limited to color, you're limited to size, and the description of preference is boxed or limited by language. Right? When you now describe that in some type of vector space, there are other dimensions that, okay, fine, they're not necessarily as explainable to some degree, but you end up getting a much different relation between items that tends to serve people or give them a much better experience. So that's in e-commerce, and I'll go a bit on this topic. And if we think about healthcare, so I go to a doctor, let's say I'm ill. I probably have COVID at this point. So there's a very, it's very important for me to get results quickly. And it's good in e-commerce to get results in under 100 milliseconds most times.
Yeah.
But now there's a much different need. I'm not just browsing, I don't want to die. And coming with that type of uh, particular motivation, when a healthcare provider is maybe showing me doctors or showing me treatments, it is on them because there's a lot of risk. If they show me the wrong thing because I didn't necessarily tell them, hey, I'm actually allergic to this type of medication, I might die. Right. So I think there is both a play on either side in terms of, let's say, how information is used to serve someone. Because if you're not in person and handing over that information to get the best recommendation from a physical doctor, you don't have to do that in an online space, right? But I do think it is
Yeah.
possible to respect people's data and give them pretty good results.
Yeah, I think in the end, it's pretty much, I would agree with what you said. It's really about providing the best solution. So if it's in the healthcare, you really want to provide the best treatment recommendation or medication or the right doctor for the person. And for that, even if you are doing that face to face with another human, you will share that information. As a
Mhm.
user, also, if you look at it that way, it's not that scary, let's say, when you need to share your personal data.
Yep. And another thing to think about there is, as you encode business logic into, let's say, a search application or any type of customer facing application, you're essentially trying to speed up the process, not always completely replace the process. So, for instance, if I was to try to get a recommendation from a doctor, yes, I know we talk about healthcare will give you certain recommendations, but maybe in the meantime, you narrow down a bunch of different things so a doctor can make a decision a lot faster. So, it's not always about the algorithm always giving me a recommendation, but it can narrow the space and the time it takes to make a decision.
Yes, and that is especially relevant when you have so many options. If we go back to the e-commerce example, if you have a catalog, maybe millions of options there, like shoes, and it's really
Mm-hmm.
easy to get lost. So you
Yeah.
also are, if you're looking for something, you also want to see the things that you're most interested in. And I think it was pretty interesting what you were saying again about the idea of the categories for the product and how much that is limited by language. And there's this approach where you can just transform it into a vector in whatever space. So maybe that's not explainable because in the end you have vectors, numbers, and dimensions that you don't clearly know what they represent. Maybe they represent colors or they represent, I don't know, seasons of the year, but it's not explainable. And I think it's not always bad that you use an algorithm that is not explainable because in this specific application for search, what you really want is to show what is relevant to people. And
Yep.
it doesn't matter why it's relevant, it just matters that it is relevant, it is what they're looking for, and they will also be happy that they found it.
Yeah, and coming back to that notion of explainable, let's say we do take e-commerce products, right? And you you take a particular search algorithm that's more deep learning based, and you train that on what people search for, not who they are, any type of personal information. They're just like, what query did you put in and what did you click on? That's all I need to know. I don't need to know anything about you. And you make certain decision. That particular model learns to arrange products, right, in terms of proximity and how related they are. And when it comes to explainability, when you actually look and you say, give me this product and these other five products come up, you as a human can intuitively understand, oh, some cool examples that I've seen is you'll see pillows, right? If you look at a particular plot and it's just like a graph with a bunch of dots on it of where products sit, you'll see a product in the camping section next, excuse me, not a product, a pillow in the camping section next to a pillow in the bed section, right? But in the store, you might see the bed section on completely one different side and camping is in a completely different place. But in the algorithms sort of understanding of how products and how language relates, it says, hey, these pillows are kind of the same, right? They're in different departments, so you end up having this machine learning based proximity. Then there's a business overlay that you end up putting on top of that, right? These things belong in the bedroom, these things belong in camping, right? So there's this
Yeah,
different labeling that people have to do.
interesting. And so this was already when you were the part of search that you were talking about. Is this already when you started working at NVIDIA that you were diving deep into search, or it was before, right?
It was before at Lucidworks. That's where I kind of spent a lot of my time. But funny enough, I did a fair amount of that in my PhD. So what I studied there, or my topic was on 2D and 3D shape matching and retrieval. So
Okay.
right now, when you go to retrieve an object from some type of search engine, you type in a text-based query, image of a dog, image of a cat. Now, when it comes for a lot of 3D or 2D type graphics or image search, you give me a particular image and I want to find other similar images, right? We didn't put in any text or whatever. But what's kind of cool about shape is a sort of fundamental property of images. So you can strip all of the other metadata, color, texture, all of that stuff you can rip out. But shape, humans can recognize objects through shape, right? So it's a sort of lasting fundamental property. But long story short, they're given a particular shape. Let's say you gave me a shape of a dog. There are different geometric properties that you leverage to retrieve other similar shapes strictly based off of the geometry. not knowing that it was a dog or a cat. So
Okay.
it's slightly different. And when you come into 3D objects, so a lot of people who do 3D designs, making scenes in digital worlds, I want a rabbit, I want this really scary looking Rottweiler. You can give a particular model and then get other similar models that you can, excuse me, then build off of, right? So thinking of the geometry and how you're trying to develop some type of machine learning feature such that similar objects are closer in this vector space and then dissimilar objects are sort of further in the vector space as well, which is pretty much what you're doing in most of machine learning
Yeah,
oftentimes.
that's pretty cool because that's it. In the end, you can take anything and really transform it and put it in this vector space. Like you're kind of engineering, for example, the 2D image into only the shapes, or the 3D image into only the shape of it. And then, can you share a bit more than how from this, working on this topic at Lucid Work, you went to work for NVIDIA?
Yeah. So when I joined NVIDIA, I actually first joined what's called the HER team, the Higher Education and Research. So I had the opportunity to work. So that team is focused on working with researchers across the world, and I was in North America. This is both at the top universities and the top research labs to do accelerated computing and to do machine learning at scale. So oftentimes there are many different problems that people want to work on that require a fair amount of compute, right? These
Mm-hmm.
large GPU clusters, thousands of GPUs, which is not something you might get to play with, let's say, if you work for a traditional, let's say, e commerce company or regular company. So at these labs, they're trying to simulate weather, they're trying to simulate different types of diseases. An interesting problem that I worked on was uh, modeling transport, right? Radiation transport. So you have this is a physics problem. You have a particular amount of radiation emanating from a particular source, and you're trying to model that or estimate the strength of radiation at certain points. And you're maybe using deep learning and a big trend that you're seeing in the field now. Any type of functions that were previously modeled, let's say empirically, people are now using deep learning to estimate those functions. So I no longer need to estimate a lot of things when it comes to numerically. So, for instance, a big thing is doing Delaunay triangulation, right? So, in order for me to do integration, right, like mathematical integration, I need to actually estimate the curvature of that space, and then you do a bunch of different integrals on all these tiny triangles. But you're just going from whatever data that you have to some number after you've integrated. So you can kind of use deep learning to do that integration for you. So that was a kind of an interesting problem. And then I
Yeah,
moved
indeed.
to the the retail team where I'm now back focused on, let's say, search and recommendations, but also more in general, what are all the problems that you can accelerate with machine learning in the retail space? So a lot of forecasting applications, and time to value is very important. So for instance, imagine you had a chain of stores across Europe and you are trying to optimize what products that you should stock, but your model takes an entire week to run, right? Therefore, it takes you a week and you're behind on certain trends when it comes to you stocking your store. But if you can finish that particular computation in a couple of hours, every day you can get the most optimized number of products that you can put into your store, right? So it has this rolling benefit to your business, if that makes sense.
Yes, it does. So interesting. I also have worked for retail and in e-commerce as well. So I did work with some forecasting
Mm-hmm.
and exactly this, trying to understand stock and demand and to fulfill the demand or not to have extra stock as well. This kind of situations. But as you also mentioned before, I worked with traditional machine learning models in traditional servers with CPU. And I am wondering, when is it that one should think about moving to GPUs, or if there is any kind of tips you can share on that, let's say that people or application or
Mm-hmm.
maybe the amount of data that would make sense to go directly to a GPU computation, kind of to leverage that power.
Yes. So I think the first thing with GPUs that I want everyone to understand. or remember, there's a big shift in the way that compute is being done. Typically, when you do any type of processing on the GPU, people would have your CPU as your main processing unit and then your GPU as this super accelerated thing. So I push my data onto the GPU and I do a bunch of stuff and I bring it back to the CPU. Now, because of different memory optimizations on the GPU, you don't necessarily need, not to say you don't need a CPU, you do need a CPU, by the way. um, you can put data directly onto the GPU. So what that means is typically data will take a fair amount of time to load into RAM or go through the CPU, then to push onto the GPU. Now that you can put data directly onto the GPU, people who train these very, very large models or train on a lot of data where you're pushing in batches of data, that data could be going in there almost hundreds of times faster. So a great example of this is the NVIDIA Merlin team, MERLIN. They're the recommendations team at NVIDIA, and they've won several recommendations competitions simply because they were able to feature engineer much faster. This is also sorry, that was the Kaga Grandmasters of NVIDIA. That's what I meant to say. So NVIDIA hired, I think, some 10 or 15 of the top Kaglers in the world, and basically told them to have fun with GPUs and win competitions. And what you end up seeing is, because you can load data a lot faster onto the GPU, that's the first step. The next is, if I have two different processes on the GPU and they want to communicate to each other, typically you would have to transfer all of that data through the CPU before. Now, because of different interconnects across GPUs, the GPUs talk directly to each other. And I'm not necessarily a hardware expert, but the caches on GPUs are a lot bigger and a lot faster. So the amount of data that you can move across the GPU is way more that you can move on a CPU. So great, you can move more data and whatnot. So the first step that I would encourage you to think about is, do you have a large amount of data to process? Okay. If you have a small CSV file, okay, you stick in pandas and whatnot. So that's NVIDIA Merlin for recommendations. So many companies that are doing deep learning recommendations at scale, you have to process a large amount of tabular data. So there's a library
Yes.
called NV and basically, instead of processing that on the CPU, put it on steroids and put it on the GPU, and you finish a lot faster. Um,
Okay, so if I
it
understand you're right, it's not only about running the deep learning models, but even the processing of the data, feature engineering, all of that is already leveraging the power of the GPUs.
Absolutely, that's actually one of the bigger bottlenecks. It's not only your training, and when you start talking, there are different levels as well. So when you go to train larger models, there is training on a single GPU, then there's training across multiple GPUs in a single node, and then you go to multi-node training. Okay. And then another paradigm shift that you will see sort of coming, and it's already there, but I don't think many people have been made aware of it, is data processing. So end-to-end machine learning, like you're doing scikit-learn, you're doing pandas. So
Yeah.
NVIDIA Rapids, you're doing all of that on the GPU. So now I can take a CSV file, let's say, or a Parquet file that's 16 gigs, 30 something gigs, push it onto one or multiple GPUs, and process my data a lot faster. And then the last thing that I'll say there, I think the most important thing you want to look out for is query time applications, where you're serving a large number of requests to users. So search and recommendations is a perfect place. Thousands of requests coming in per second. And if you use GPUs, you end up getting a much better total cost of ownership, because on a single piece of hardware, I can host multiple models. So if you check out NVIDIA Triton Inference Server, that's a server that basically hosts your model and handles all the incoming requests, does all the load balancing in Kubernetes in your particular cluster. But what you end up doing is you leverage the full capabilities of the GPU to just serve more queries at scale.
Yeah, you're right. Then really search is the perfect application for that, because the more products you have, more customers you also have, and you have to just reply faster to them. So that makes sense. Thank you. We
Definitely.
have a question here from Melvin. I don't know if we can read that completely here.
Yes.
So,
So I think that the crux of the question is, I didn't necessarily have a programming background, but in my PhD, I did mention an emphasis on machine learning and intelligence systems. Um, so I would say maybe how I got to that point was one, you have to jump in and learn, right? So during my PhD, I used a lot of MATLAB. Actually, I didn't use a lot of Python in my PhD. And when I got to my first job, that's where I learned Python and you picked up certain skills. So coming back to maybe that point, there's a lot of fundamentals that I think as you go in your data science career, it's important to spend time on the fundamentals, not the libraries like doing scikit-learn and stuff like that. Really, the fundamentals of what are happening, understanding the math, and I think once you're a little more comfortable with the math, your programming is a lot more streamlined because you know exactly what it is you're trying to achieve when you go to code. So maybe your code is not as elegant oftentimes, but you can get something to work because you understand the fundamentals, you understand why this particular algorithm works over another one, if that makes sense.
Yes,
Hopefully that
and
answers your question, Melvin.
yeah, I couldn't agree more. I also come from a background in applied math, so I did learn how to program in university, but we use it MATLAB as well.
Mm-hmm.
And the idea of understanding the foundations, really like linear algebra and calculus and statistics, that is what you will need to understand any kind of algorithm or any kind of implementation. So nowadays, yes, you can simply import libraries and start modeling. But when you understand what's behind it, it also makes it easy for you to even choose what algorithm to start from or to choose hyperparameters. And yes, the programming language or the, let's say, the libraries that are coming up, this is something that you always have to learn because there's always something new coming up.
Yep.
We are almost, yeah, we are already at the end of the session, unfortunately, because we could talk a lot more. I just want to also ask you to let people know where they can find more about you, especially if they want to know more about search, where
Mm-hmm.
they can find you.
Definitely. So I don't know if I could put. Can I put it in the chat? I'll put my email in the chat, my work email. If you have any questions about NVIDIA, feel free to reach out in terms of the platforms that we have, things with you're doing stuff on a GPU. Always happy to chat with anyone. Another thing that you can definitely check me out on is I run a podcast called the Caribbean Data Science Podcast, and that's just to highlight stories of people from the Caribbean region doing things in machine learning. But what you end up finding out is a lot of these people are in top companies as well, right? So some of the people that run Facebook AI research, Samsung AI research, they're from the Caribbean. So you get to
Nice.
kind of get to know them and understand their career journeys. If you're looking for a good conference, machine learning conference, check out the Southern Data Science Conference. We just had an online event. The stream is online. And reach out to me on LinkedIn. Just look for Mark Moyou. I think my name is pretty unique from that standpoint. So you should be able to find me there. And yeah, we can go from there.
Thank you, Mark. It was really fun talking to you today, even though short. But I would also invite you to keep the conversation going. We have the AI Guild Slack workspace as well, so people can
Absolutely.
also find you there. And hope to see you maybe in some online event soon.
Yes, definitely. You'll have a great day. Take care.
Yes. Thank
All
you.
right. Bye.
Bye.